propane tanks are extensively used in the kitchen, it's not enjoyable, or however, to discover you've run out of gas halfway through a meal. On a hot day, gauges are used to measure the pressure inside gas tanks that read greater than a cool day. When deciding whether or not to replace the tank before your next cookout, keep the air temperature in mind. In this article, we'll go over Lussac'S Law in detail, including its formula and derivation.
So what is Lussac'S Law? Lussac'S Law is a gas law which states that the pressure exerted by a gas of a given mass and kept at a constant volume varies directly with the absolute temperature of the gas. In other words, the pressure exerted by a gas is proportional to the temperature of the gas when the mass is fixed and the volume is constant. This law was formulated by the French chemist Joseph Gay-Lussac in the year 1808. The mathematical expression of Lussac'S law can be written as follows. P is directly proportional to T, or P over T equals constant, where P is the pressure exerted by the gas and T is the absolute temperature of the gas, and K is a constant. The relationship between the pressure and absolute temperature of a given mass of gas at constant volume can be illustrated graphically as follows. From the graph, it can be understood that the pressure of a gas kept at a constant volume reduces constantly as it cooled until the gas eventually undergoes condensation and becomes a liquid. So the formula and derivation. Lussac'S law implies that the ratio of the initial pressure and temperature is equal to the ratio of the final pressure and temperature for a gas of a fixed mass kept at a constant volume. This formula can be expressed as follows. P1 over T1 equals P2 over T2, where P1 is the initial pressure, T1 is the initial temperature, P2 is the final pressure, and T2 is the final temperature. This expression can be derived from the pressure temperature proportionally for gas, since P is proportionally for T for gases of fixed mass kept at constant volume. P1 over T1 equals constant, or initial pressure over initial temperature equals constant, and P2 over T2 equals constant. Final pressure over final temperature equals constant. Therefore, P1 over T1 equals P2 over T2 equals K, or P1 times T2 equals P2 times T1.
So this is the solving exercise in Gay-Lussac's law. So the pressure of a gas in a cylinder when it is heated to the temperature of 250 K is 1.5 atm. What was the initial temperature of the gas if its initial pressure was 1 atm? So initial pressure is equivalent of P1 is equal to 1 atm, and final pressure is P2 is equal to 1.5 atm, and the final temperature is T2 is equal to 250 K. As per Gay-Lussac's law, P1 multiplied by T2 is equal to P2 multiplied by T1. Therefore, T1 is equal to P1 multiplied by T2 over P2 is equal to 1 multiplied by 250 over 1.5 is equal to 166.66 Kelvin.
Examples Lussac'S law is when a pressurized aerosol can, such as deodorant can or spray paint can, is heated. The resulting increase in the pressure exerted by the gases in the container, owing to Lussac'S law, can result in an explosion. This is the reason why many pressurized containers have warning labels stating that the container must be kept away from fire and stored in a cold environment. An illustration describing the increase in pressure which accompanies an increase in the absolute temperature of a gas kept at a constant volume is provided above. Another example of Lussac'S law can be observed in pressure cookers. When the cooker is heated, the pressure exerted by the steam inside the container increases. The high temperature and pressure inside the container cause the food to cook faster.